What would you measure to find out whether a river is still alive? Most of the world measures the water. How much of it people are pulling out? How much fertilizer is washing into it? Those numbers are official and objective, and they feel like hard science. Then somebody finally checked whether they pointed the places where freshwater animals are actually dying. They did worse than random. 4 things before we go under the surface. You will find out why a sliver of the planet holds more than 1/10 of everything alive on it. You will meet animals that disappeared from lakes you have never heard of. You will see how the world really decides which places get saved. And you will find out what does predict where freshwater life is vanishing, because something does. Start with a strange piece of arithmetic. Gather every drop of liquid fresh water sitting on the surface of the earth. Every river and pond and swamp and flooded field. Spread all of it out on the map and it covers less than 1% of the planet. I am going to call that the thin film. It is the wet part of the world that is not salt, and more than one species in 10 lives inside it. Think about what the thin film means if you live in it. A tuna has a whole ocean. A wildebeest has a continent to walk across. A blind shrimp in a limestone spring in Mexico might have one pool the size of a parking space and no second address anywhere on the planet. None of that is a metaphor. So how do you protect a world you cannot see? You cannot see it, so you do not pay for it. Conservation has a face, and that face is furry. Picture the last wildlife campaign that genuinely moved you. A panda chewing bamboo. A tiger in the snow. A whale breaking the surface. Now try to remember the last time anybody asked you to care about a crayfish. Nobody ever has. For more than 20 years, the global inventories of which species are in trouble have been built around 4 groups: amphibians, birds, mammals, reptiles, animals with 4 legs or the evolutionary memory of 4 legs. Those are the ones we film and the ones we count and the ones we write checks for. Look at the goals the world's governments actually signed. One of them is called life on land. Another is called life below water, and it means the sea. Fresh water fell straight down the gap between the two. A river became a line in the resource accounts instead of a place where anything lives. And whatever nobody counts is a thing nobody misses. Here is what happened inside that gap. Between 1970 and 2015, the world lost about 1/3 of its monitored wetland area. It lost it roughly 3 times faster than it was losing forest. And of the rivers longer than 1,000 kilometers, more than 1/3 no longer run free along their whole length. Dams mostly. Which brings us to a very practical problem. A minister has money for one river basin and a map with thousands of them on it. How does she choose? She uses a surrogate. A surrogate is a stand-in. It is something cheap to measure that you hope rises and falls with the thing you actually care about. Your doctor uses cholesterol as a stand-in for a heart attack that has not happened yet. Freshwater planning leans on 2 stand-ins. The first is the famous animals. If you know where the threatened frogs and birds and mammals are, the thinking goes, you know where to draw your lines. The second stand-in is the water itself. Water stress, which is how much of a region's supply people are already using up. Nitrogen, which is fertilizer running off farmland until algae strip the oxygen out of the water. One of those 2 stand-ins turns out to work far better than the specialists expected. The other one fails so badly that leaning on it may leave rivers worse off than having no plan at all. And here is the part that should bother you. Until very recently, nobody had ever run the test. Not properly. Not at global scale. Which one would you have bet on? There is a harder problem hiding underneath this one. Some of the richest freshwater habitat on Earth is underground. Karst is landscape built from rock that water slowly dissolves, so it fills up with caves and springs and hidden channels. Picture a limestone hill with an entire river running inside it. Crabs and crayfish live in there in tiny trapped populations. Roughly 1 in 4 threatened freshwater crabs and crayfish depend on that kind of habitat, about double their share of the group as a whole. So how do you survey an animal in an aquifer you cannot even enter? So what is actually alive down there? Far more than you would guess. The thin film holds about 1/3 of all vertebrate species on the planet, and something like half of all the fish. Half. Every salmon and carp and catfish and every strange little cichlid crowded into less than 1% of the surface. And the fish are the easy part. If a hidden crisis that nobody was even measuring until somebody finally decided to count it is the kind of story you like, subscribe. We go digging up a new one every week. How many lives does a dragonfly get? 2. It spends years underwater as a larva hunting in the mud, and then a few brilliant weeks in the air above it. So a dragonfly needs 2 worlds stacked on top of each other. Nearly 3/4 of the threatened dragonflies and damselflies rely on forest for the flying half of that life, while the larvae need the wetland underneath. Ruin either half and the animal is 2 worlds. How sure can we be that right? What's stat and toss? Now the uncomfortable part. When the assessors work through a species and the evidence is too thin to say anything, it gets filed as data deficient. Data deficient is not a verdict. It is a shrug. It means the animal is known from a few specimens in a museum drawer in a collection site from decades ago, and nobody can honestly say whether it is thriving or already gone. Close to 1/4 of these freshwater animals sit in that category. Among the famous land vertebrates, it is only about 1 in 10, which is exactly why the extinction count is almost certainly too low. Since the year 1500, close to 90 freshwater species have been confirmed gone for good. That sounds small until you see what sits beside it. Nearly twice as many again are already tagged as probably extinct, which means the experts believe they are finished but cannot prove the last one died. Almost 50 of those sit in a single lake basin in East Africa. Go to the Philippines and you can watch how that happens. There is a lake called Lanao, high up on the island of Mindanao, that produced a whole flock of small fish found nowhere else in the world. The usual account blames introduced predatory fish along with heavy fishing and changes to the water. 15 of those species are now listed as extinct, and every single one was endemic to that one lake. A branch of the tree of life lived there, and now it does not. Mexico lost 15 species of its own. And 11 freshwater fishes are now listed as extinct in the wild, which means the species is still here, but its river is not. They exist in tanks. 8 of those 11 came from Mexican waters. Somewhere tonight a pump is keeping an entire species alive. So how do you actually count the animals in every river and lake and stream on Earth? You do not do it from a satellite. You do it the slow way. More than 1,000 species experts. More than 100 workshops spread across 2 decades. People in rooms with old museum records and field notes, arguing species by species about whether a population is holding or falling. It all feeds one system, the IUCN Red List. In the end, they worked through more than 23,000 animals. Freshwater fishes, plus dragonflies and damselflies, plus the crabs and cribs and shrimps. That is about 5 species in Sambrices. The headline result is a single number, and it is worth holding on to. Close to 1/4 of them are threatened with extinction. Now, the comparison that makes it land. Among the famous land vertebrates, the figure is just under 1/4 as well. The animals nobody funds are in almost exactly the same trouble as the animals everybody funds. Crabs and crayfish come off worst at around 3 in 10. Fishes are just behind them. Dragonflies are lower or roughly, and the reasons are not the ones you would put on a poster. Pollution touches more than half of the threatened species, mostly runoff from farming and untreated urban wastewater. Dams and water extraction hit around 4 in 10 of them. then farmland conversion, then invasive species and disease. Most threatened freshwater animals are facing several of these at once, and the confirmed extinctions come disproportionately from invaders and from over-harvesting. Which leaves the question we started with. Do the numbers actually use tracked? Here is the answer to the bet. The famous animals do work. Ranking places by threatened frogs and birds and mammals and reptiles get you most of the way to the ranking you would get from freshwater animals themselves. Not perfectly. It slips badly when you go hunting for the species trapped in one spring or one short stretch of river. But as a rough map of where the trouble is, the pandas of this world earn their keep. And the water numbers. They did not just underperform, they scored below zero. Below zero means worse than random. Throw darts at a world map and you would pick better places to protect than water stress and nitrogen levels pick for you. The most objective-looking data in the entire field is a worse guide to freshwater life than pure chance. Think about what that costs. Money moves to wherever the metric points. If the metric points away from the springs and the karst and the ancient watersheds where the rare things actually live, the effort lands in the wrong valley while the last population quietly disappears. A target built on water alone protects water. It does not protect what is swimming in it. One honest caution before we finish. None of this proves that a frog somewhere makes a fish survive. It is a test of where to look and not a test of what causes what. And with about a quarter of these species still filed as data deficient, the real share in danger could be lower than a quarter or very much higher. Which is the real lesson here, and it is much bigger than rivers. We protect what we measure, and we measure whatever we already decided was worth noticing. For most of a century, that decision was made by whatever photographed well. Somewhere under a limestone hill tonight there is an animal with no name, no footage, and no budget line. The world we managed to keep will be the world we bothered to count.